Dr.Ashwin Dobariya welcomes you to Programming in C video series. In this video, we will discuss a very important concept, that is typecastings in C language. Let's see what is the use of typecasting in C language. First of all, we will see what is the overall concept of typecasting and where we will use it in our program. So in this entire video, I will explain the two different types of typecasting available in C, and we will also discuss a various type of examples so you can get the overall idea about the typecasting. And actually, whenever we do arithmetic operations, at that time the typecasting concept comes into the pictures. So first of all, what is typecasting? So typecasting is a process which converts a value from one data type into another data type, depending on the type of operands or variables. We know that, friends, we already discussed the concept of operand. Operand means it may be a value or may be a variable on which we are performing certain arithmetic operations. So here compiler internally converts the value from one data type to another data type. One important thing, where exactly the typecasting happens. So it applies generally whenever a program expression is in a mixed mode. Now what do you mean by mixed mode? Mixed mode is nothing but, suppose this is an arithmetic expression. So mixed mode means the data type of the operands are different. Suppose here x is an integer and 2.0 is a float. So one operand or one variable is integer, another operand is a float. So it's a mixed kind of expression. Now here, if we consider x and y, so x and y both are declared as an integer. So here again, this is a similar data types of variable. So here the operations output is different, here the operation output is different. So let's see the same example, then we will continue with the concept of typecasting. Here we have declared two variables, x and y, both are integer, and the initial value of x is 5 and y is 2. And one more variable we have declared z. Now we want to perform like a division operation. So z is equal to x upon y. Now x value is 5 upon 2. So as per mathematics, we know that what is the output? 2.5, right? 2.5. But actually here x is integer, y is also integer. So if you perform the arithmetic operations on integer operands, if all operands are integer, then output will be also integer. So out of 2.5, it will ignore 0.5. So actually it happens like that. Suppose z is equal to 5 upon 2. So as per mathematics, output should be a 2.5, right? But as I told you that the compiler generally consider the data type. So here 5 is also integer, 2 is also integer. So integer, two operands are integer, then it will generate the output of integer part only. So here 0.5 will be ignored. So actually what happened? 5 upon 2, the output will be considered 2 only. Now the thing is, the output of this is 2. Now this 2 will be stored into z. Now it will check the data type of z. Yeah, z is a float. Then z is a float means it will not store only 2. So what z will do? Z will store like this, 2.0. So there is no difference between 2 and 2.0. Both are equal. But here, see what happened exactly. So compiler consider the data type of the operands. If both the data types are similar, then it will generate. If it is similar means it may be a both data types are integers or a float. So if it is a float, then there is no issue. Then it will generate a float answer. But if both are integer, then it will ignore the integer floating part, and it store to the variables. Now the same concept over here. Say here again both variable x and y, float z is equal to x. Here x is 5, so x is integer. Divide by what I have done over here. Instead of 2, if I mention only 2, it is considered integer. But if I mention 2.0, so now what happened? 2.0 means it's a float. Now actually what compiler will consider in this case? Here 5 is an integer, 2.0 is a float. It means it's a mixed mode. And if one of the operand is a float, remember, if one of the operand is a float, then the output of that expression is a float. Now we know that 5 upon 2 means it's a 2.5, and see here 2.5 it will generate because one of the operand is a float, and this 2.5 will be stored into Z. Now it will also check the data type. Z is a integer, right? Float. Then it will store the 2.5. So this is again the one of the very important concepts of the typecasting. One more case here we will discuss. Suppose we have declared Z as an integer, right? And if we perform the same operation, what happens? Now see here. Here integer is a Z. Z is declared as an integer. And now see the expression is a 5 upon 2.0. So one operand is a float, another is an integer. So it's a if one of the operand is a float, then ultimately the result will be a float. So actually result is 2.5. Now what happened? This 2.5 we are assigning to the Z. And now see the data type of Z is an integer, and we know that integer variable will never accept the decimal point. So in that case Z will be stored only a 2. It will ignore the 0.5. Now so here we have discussed three different scenarios. One is if both the operands are integers, then the output is integer and assigned to the variable. If it is float, then it consider 2.0. Another is if one operand is a float, then output will be a float, and if we store into the float variable, the same output will be stored in the variable. Now suppose if the assigned variable is integer, and suppose if your generate output is float, then again it will ignore the decimal point because here Z is declared as a integer. So this is the overall concept of typecasting. Now let's we go into the depth, the type of typecasting. Now in C language there are two kinds of typecasting process happen. One is the implicit typecasting. Now implicit, the meaning itself say internal. So implicit typecasting means that is also known as a type conversion, and generally implicit typecasting is performed by compiler itself according to the data type. Now see here in that case if we consider, so x upon 2.0, so what compiler do the type conversion? Here compiler will do the type conversion. It will verify here one operand is integer, another is the float. Now which is the lower data type in terms of size? So integer occupies 2 bytes, float occupies 4 bytes. So integer is a lower data types, right, in terms of size. So compiler will automatically do the type conversion, and here type conversion means what? Actually compiler is promoted the data type. So here the lower data type is promoted into the higher data type according to the another operands. So here another operands is a float. So what internally it will do, that 5 will be promoted as a 5.0, right? It's a type conversion. Now 5.0 and 2.0 both are float, then it will generate the float answer, right? So here automatically type conversion will be done by the compiler, but here it is not required because x is also integer, y is also integer, so there is no automatic type conversion happen in these expressions, right? But here it will do the type promotion. So the first type of implicit typecasting, that is known as a type conversion, and another types of typecasting, that is explicit typecasting, and that is force casting is also known, and this is done by the user or a programmer. Programmer can forcefully convert one data type to the another data types. How? Let me see with the example. So first is the implicit typecasting, or it is also known as a type conversion. So implicit typecasting, it is a automatic type conversion because it is performed by the compiler. So it works in such a way that, so a data type of a variable or a operand that is smaller in size, then internally it converts to a variable or a data type with the longer number length or a higher size of data type variables. As I told you in the previous example, suppose the same example over here, integer x is equal to 5, float y, and y is equal to 1.5 plus x. Now x is integer and 1.5 is a float. So what the compiler will do, that 5 will be internally promoted or automatically convert into the float. So it will consider 5.0 instead of 5. So 1.5 plus 5.0, it becomes 6.5. So output will be this. If we talk about the another type conversion, so see here user has not mentioned anything, but compiler itself convert internally from one data type to another data type. Now here integer x, then character ch is equal to single quotation a. Now what we are doing over here, ch is assigned to x. So here ch is occupies 1 byte and x is integer 2 byte. So internally this character is considered in a decimal value, so it's a 65, right? 65 is an integer and it assigned to the integer variables. So in that way the compiler is doing a type conversion. If we see the sequence, okay, how compiler is convert from one data type, so automatically implicit type conversion is done by compiler generally from the lower data type to the higher data type. So lower data type means in terms of size, so integer. So first it will verify which is the lower data type variable over here, and that data type is promoted to the higher data type according to the another operand. So here 5.5 it's a float, 2 is the integer. So see here integer is a lower and here it will convert integer to the float. So internally it looks like this. Internally 5.5 will keep as it is, plus 2 is promoted as a float, so 2.0, then it will perform some operations and the answer will be 7.5. So this is the, you can say, the level of the type conversion. The compiler always start the conversion from the integers, then unsigned integer, long unsigned, long, then unsigned long, float, doubles and long doubles, right? And suppose if one operand is integer, another operand is long double, then first that integer will be converted into the long double. So this is the perform automatically by compiler. That's why it is known as a implicit typecastings, and that is also known as a type converter. Now the second type of typecasting in C language, that is explicit. And explicit, the word itself says the user defined, programmer defined, that is known as a explicit, right? And it's a force casting. Force casting means we are compulsory saying the compiler you convert in this data type. So in explicit typecasting, the programmer has to mention explicitly data type with operands in an expression for conversion process. So the process of explicit casting has higher priority than the implicit typecasting, right? So suppose in any expressions there are two options, right? The compiler also having the options in implicit and explicit, but suppose explicit type conversion will be given a higher priority. So this is one example how we can mention typecasting. So into bracket we have to give a data types and with the operands. Now it's very general example, like to calculate a simple interest. So in simple interest, PRN, suppose you have declared as integer, divide by 100. So here see PRN, 3 variables are integer, 100 are also integer. Now what happened? All 4 are integer, then whatever output will be generated, that will be integer. So it will not a perfect simple interest. So here we can convert float. So here it is the explicit typecasting. So what it will do, whatever output of this PRN multiplication output will be first converted into float. So suppose this is a 5000. So 5000.0 first it will convert into float. Now one operand becomes a float, then the another operands will be automatically converted into the float by the compiler. So here say first is the explicit typecasting, after that the compiler will do the internal typecasting, right? So here we can also mention this float like this also. There are many options to write these statements, like z is equal to float, then we can mention float, then p multiplied by r multiplied by n divided by 100, right? So here see what happened, first p will be converted into float, and we know that if one of the operand is float, then overall output will be a float, right? Even suppose if you don't want to write this float, right, then you can write the float over here also. Our ultimately objective is one of the operand we have to make as a float, and if one of the operand is float, then finally the overall output will be a float, right? So we can mention the explicit data types with the particular variable also, or with the entire expression also, right? If we mention like this, so here we have what happen in that, first it will calculate this, and whatever answer of this, it will first convert into float, then it will perform the remaining. So this is known as a explicit, because user has mentioned this, I want to convert this value in the float, right? And this where the typecasting is generally required. So these are the general rules you have to remember in terms of programming, in terms of compiler. If both the operands, if both the variables are integer, then output will be integer. If first operand is integer, second is float, then output will be float. If first operand is float, second is integer, then it is float. And if both are float, then float. So overall, if one of the operand is float, output will be float. But if both the operands or variables are integer, then output will be integer. These rules we have to remember in terms of programming or in a compiler. Now see here. If we take this all example as a general, so here x is integer and y is float. Now what happened over here? 5 upon 2. So 5 upon 2 both are integer. We know that if both are integer, then actual as per mathematics output is 2.5, but both are integer means it consider only 2, and the 2 is assigned to what type of variable? Integer. So x is integer, so 2 is assigned to x, and the output is 2. Now what happened over here? The same expression, float 5. So it's a explicit type conversion, and explicit means first 5 is converted into float. So how 5 is considered? 5.0, and 5.0 divided by 2. So 2 is integer and this is a float, right? So 2 is again internally promoted. 2 is again internally promoted as a float, right? And one of the operand is float, then output is considered 2.5. Now see here, actual output is generated 2.5 because one of the operand is float, but the 2.5 we are assigning to x, and x is declared as an integer. An integer variable cannot store the decimal value. That's why again it will ignore 0.5. So output is only 2. Now let me continue with the same example, 5 upon 2. And now we are storing the answer in the float variable. Now see here, 5 upon 2 both are integer, and we know that both are integer, then output will be 2 only instead of 2.5, and because here 5 and 2 both are integer, so that 2 is assigned to y, and we know that y is a float, so it will not store only 2 but it store 2.00. Now in the same case, if we convert one of the operand as a float, so here 5.0 divided by 2, so it will generate 2.5, and now 2.5 we are assigning to the float variable, then output will be a 2.5. Now we can convert any one of the operand as a float, either 5, or we can also convert 2 as a float. Or if you don't want to write float, then instead of float you can mention 5.0. So the meaning of this statement and this statement both are similar. The meaning of this statement and this statement both are similar. So if the number is like that, then you can add 2.0, right? So in that way we can convert the typecasting in the programming. So I hope friends this concept you have understood, and in this video description part I also mentioned certain another English theory, English version theory and practical video for your reference, and in the next video we'll discuss another important concept, that is operators precedence or a priority and associativity. So in sometimes in single expressions, if you have used multiple different types of operators, then how the compiler will give a priority and associativity, that is very much important concept that we'll discuss in the next video. So friends, please share these videos with your friends, like these videos, and for getting the updates of this video, please subscribe this video. So again, we'll see you in the next video. Thank you everyone.